All right, so diving in this time, it's a bit of a heavy one, but a pivotal moment in spaceflight history, really. We're talking about Apollo 1.
Yeah.
Originally, AS-204. This was meant to be the first crewed test for the Apollo Command and Service Module.
The
CSM, right.
Yep.
And the plan was low Earth orbit, see how it all works, test the launch procedures, the ground tracking, the whole shebang. Liftoff was supposed to be February 21st, 1967.
Big day. A lot riding on it, as we know now.
Oh, absolutely. And to really understand what happened, what went wrong, we've got a pretty substantial amount of material to go through, wouldn't you say?
We do. We've got, we've got your notes from April 6th of this year.
Right.
We've got excerpts from the Barron Report. Then there's those transcripts from the House Subcommittee on NASA oversight hearings, of course. And then there's mentions of something called the Phillips Report, which we'll have to unpack a bit.
Right.
There's the Apollo Program Safety Modifications document, the Apollo 1 Systemic Failure Analysis.
Right.
And the Apollo 1 fire causes, investigation, and redesign. So, yeah, quite a reading list.
Comprehensive is one word for it, yeah. So the point of this deep dive, then, I suppose, is to understand the systemic issues, right? The things that were overlooked, the failures that led to the Apollo 1 fire, to look at the fire itself, the investigation, and how they made things safer afterward. We want to really track the timeline, see what they were trying to achieve, and then, confront the reality of what happened, all based on this mountain of data.
Absolutely.
So where do we even begin? I mean, the spacecraft itself, right? The Apollo CSM, as it arrived from North American Aviation, it had something called a Conditional Certificate of Flight Worthiness, which sounds a bit iffy right out the gate.
It does, doesn't it? I mean, conditionally, you think, well, what are the conditions?
Exactly. And the condition was a rather hefty 113 incomplete, what they called planned engineering changes.
113? Wow. It's not exactly ready to roll, was it? More like a work in progress.
It does seem that way, yeah. And on top of that, after it was delivered, there were another 623 change orders, things that needed fixing or changing. It makes you wonder what state it was in when they said, okay, this is good enough for testing.
Yeah. You've got to wonder about the quality control there, haven't you?
Really? I mean, was it truly ready for a crewed flight? I don't know. And to make matters worse, Joseph Shea, he was the ASPO manager.
The big cheese, head honcho of the Apollo Spacecraft Program Office.
Right. He signed off on it, said it was acceptable. So that brings up questions about the standards. What were they accepting as good enough?
Yeah. Big questions. And you wonder, did that kind of this'll do attitude, did that set a bit of a precedent?
Potentially, yeah. And then you've got the whole issue of testing and risk assessment, or the lack of it, in some areas. Deputy Administrator Siemens, later on, he said that not doing a fire test, specifically a fire test, on the command module before they did this plugs out test, he considered that a huge error in judgment.
Yeah. I mean, in hindsight, that's a massive oversight, isn't it?
It really is. So this plugs out test, for anyone listening who's not familiar, it was basically to see if the spacecraft could run on its own power, without being hooked up to all the ground support equipment.
Like a dress rehearsal for the power system.
Exactly. But they were using pure oxygen in the cabin at higher than normal pressure, and no one seemed to think this was particularly risky.
Right. But we know now, pure oxygen under pressure, everything becomes incredibly flammable. Things that wouldn't normally burn, they go up like a torch.
It's a completely different environment. And the crew, they actually raised concerns about that, They saw all this flammable material, nylon netting, Velcro, all over the place.
They weren't happy about it, were they?
Not at all. They brought it up with Shea.
And what did he do?
Well, he told them to remove it, but he didn't actually supervise the removal.
He didn't. So who knows if it actually happened?
Well, Buzz Aldrin later said that, yes, the material was replaced, but the fact that the crew had to push for it, that it wasn't just standard procedure, that's worrying.
Definitely.
Yeah.
It suggests, maybe they were cutting corners. Maybe safety wasn't the top priority.
It does. And it wasn't just the spacecraft itself, the simulator, which is obviously vital for training, that was behind schedule.
Yeah. The engineers were struggling to keep up with all the changes to the spacecraft, weren't they?
Exactly. So Grissom, he was trying to train for a mission where the target was constantly moving,
Frustrating, to say the least.
Incredibly. And speaking of frustration, the communication within the program was also a mess, it seems.
Yeah, it was more than just technical issues, wasn't it? There was this sense of of people not being heard.
Right. The crew, they made this this sort of joke portrait where they were going over Shay's head, which suggests they weren't happy with the communication channels.
Trying to get someone's attention? Make a point.
And during the plugs out test, Grissom said, "How are we going to get to the moon if we can't talk between 2 or 3 buildings?" I mean, that's pretty chilling knowing what happened.
It is, yeah. You can hear the frustration in his voice, can't you?
Absolutely. And then you've got this Phillips report.
Ah, yes. A bit of a bombshell, that one.
It was an internal NASA document, right,
Yeah.
detailing all sorts of problems with North American aviation.
And it turns out NASA Administrator Webb, he didn't even know about it.
Apparently not. Senator Mondale, he's the one who revealed it, which, suggests some serious compartmentalization within NASA, doesn't it?
It does, yeah. I mean, if the head of NASA doesn't know about a report highlighting major problems with the prime contractor,
Yeah.
that's a huge communication breakdown.
Huge. And when Congress found out, they were not happy, to say the least. They accused NASA of being evasive, of lacking candor.
Yeah, it was a major PR disaster for NASA.
It really was. And then you have Thomas Barron. He was a missile pre-flight inspector at North American Aviation.
Right, he was the one who testified before Congress, wasn't he?
He did. And his testimony, well, it was pretty damning. He had this background in research, experience with government contracts, and he said things like they were using non-certified parts in the spacecraft.
What, like dodgy epoxy?
Yeah, things like that. Epoxy, paint, tape, stuff that wouldn't be removed before flight. And based on his experience, he believed that NAA, North American Aviation, they had broken their contract with the government, in terms of safety.
Serious accusations.
He also talked about this conversation he had with an NAA technician, Al Holmberg. Apparently, Holmberg said he knew what caused the fire and that the astronauts had seen smoke before it even started.
And that they'd been struggling to get out for 5 minutes.
Yeah. But Holmberg denied ever saying any of that under oath.
So it becomes a bit of a he said situation.
It does. But Barron, he put together this 500-page report filled with details about issues with personnel, parts, procedures, safety, the whole 9 yards.
500 pages.
Wow. It was a lot. So even if some of his claims were disputed, there was clearly something going on at NAA, right? Some serious concerns.
Yeah. And let's not forget that Phillips report. Even though we only have glimpses of it, it's clear it pointed to some big problems at North American Aviation.
Yeah.
And it caused quite a stir when it came out, a lot of embarrassment for NASA.
Absolutely. So you've got this picture emerging, right? A spacecraft with known issues, safety risks being downplayed, the crew voicing their concerns and being ignored, communication failures everywhere, and serious doubts about the main contractor. It's a recipe for disaster, isn't it?
It really is.
Yeah.
And sadly, on January 27th, 1967, that's exactly what happened.
The day of the plugs out test. It's important to remember this wasn't supposed to be a dangerous procedure. The rocket wasn't fueled, no cryogenic stuff, the pyrotechnics were all disabled.
Right, just a systems check, really.
Yeah.
But as we know, things went very wrong.
Terribly wrong. So the crew, Grissom, White, and Chaffee, they get into the command module around 1:00 p.m. Eastern Standard Time.
All suited up, ready to go.
Right. And almost immediately, Grissom reports this weird smell like sour buttermilk.
Which they later figured out wasn't related to the fire, but still, not a good sign, is it?
Not at all. It's like a foreshadowing of something bad. So they halt the countdown, investigate the smell, and eventually resume the test in the afternoon. And then they pressurize the cabin with pure oxygen, 16.7 psi.
The stage is set.
Yeah, and you can hear it in the recordings, the frustration in Grissom's voice. They're having trouble communicating, things aren't going smoothly. And then at 6.31 and 4.7 seconds p.m., there's this sudden spike in the voltage on AC bus 2.
A blip. A tiny anomaly.
And just a couple of seconds later, someone shouts, "Hey," or maybe "fire," or maybe "flame." It's hard to tell. And you hear shuffling noises, probably Grissom moving around.
Panic setting in.
And then, just over 2 seconds later, a chilling message from Chaffee. "We've got a fire in the cockpit," a short silence, a garbled transmission, and then a cry of pain.
It doesn't bear thinking about.
Ed White, he tries to open the hatch.
But it's designed to seal tighter under pressure, isn't it?
Exactly. And the pressure is rising rapidly because of the fire. It hits 29 psi, and the inner wall of the command module ruptures. Flames and toxic gas pour out.
And the rescue efforts, they were hampered, weren't they?
They were. It took them 5 minutes to get all 3 layers of the hatch open.
5 minutes. An eternity.
It was. And by then, it was too late. All 3 astronauts, Grissom, White, Chaffee, they were gone. Carbon monoxide poisoning, that was the primary cause of death.
Horrific. A terrible, terrible tragedy.
Absolutely. The Accident Review Board, they went through everything, and they identified several key factors. First, the ignition source. Most likely, it was an electrical arc somewhere near the floor, close to the environmental control unit.
They thought it might have been a stripped wire, a silver-plated copper wire near a coolant line that was leaking. And with all that pure oxygen, electrolysis becomes a real danger.
Right. And of course, the pure oxygen itself, that was a major factor. At 16.7 psi, it turned the cabin into a tinderbox.
North American Aviation, they'd actually suggested using a mixture of oxygen and nitrogen, which would have been much safer.
But NASA overruled them.
And Siemens, he admitted later that was a big mistake. Not doing a fire test and using pure oxygen, those are two fatal decisions.
Then there was the hatch. The way it was designed, it sealed tighter the higher the pressure got inside. So when the fire started and the pressure built up, it became impossible to open.
They could have used an outward opening hatch like they had on the Mercury capsules. Those had explosive bolts, so they could be opened quickly in an emergency.
Right. But NASA rejected that idea.
Another decision that came back to haunt them.
And then there was all the flammable material inside the cabin, the Velcro especially.
Yeah, the crew had warned them about that, hadn't they?
They had. It was a death trap waiting to happen.
And finally, there was the issue of emergency preparedness. They simply weren't ready for something like this.
Not enough rescue personnel, the wrong kind of gas masks.
They just hadn't thought it through.
So it's not just about the immediate causes of the fire, is it? There were systemic failures all over the program.
Absolutely. Starting with the design and manufacturing. That CSM, it was delivered with a conditional certificate of flightworthiness. Hundreds of changes needed. The crew's concerns about the flammable materials, they weren't taken seriously enough. The simulator was behind schedule.
And NASA, they weren't doing their job properly either. They accepted a faulty spacecraft, didn't do enough testing, didn't assess the risks properly. They didn't listen to the engineers who said they needed to do a fire test.
And the communication, it was terrible. The crew couldn't get their concerns across. Nobody at NASA seemed to know what was going on. They weren't being straight with Congress.
And then you've got Barron's testimony. He talked about low morale at North American Aviation, people not caring about their work, cutting corners. Whether all of it was true or not, it paints a worrying picture.
It does. It suggests a culture where safety wasn't the top priority.
So after the fire, everything changed. They stopped all manned flights for 20 months.
They had to go back to the drawing board, rethink everything.
They completely redesigned the command module, the Block 2 version. They changed the cabin atmosphere for launch using a mixture of oxygen and nitrogen to reduce the fire risk.
Much safer.
They replaced the flammable material in the spacesuits with beta cloth.
Fireproof.
They put in a new hatch that opened outward and could be jettisoned in seconds. They covered the wiring and plumbing, used better materials, and they tightened up the documentation and procedures.
Basically, they learned from their mistakes.
They had to. And it wasn't just the hardware, they changed the culture too. Gene Kranz, in Mission Control, he instituted this tough and competent philosophy.
Accountability, attention to detail, no more cutting corners.
Exactly. And they renamed AS-204 to Apollo 1 to honor the crew. Apollo 2 and 3, those designations were never used. The Saturn IB rocket that was meant for Apollo 1, they used that for an unmanned test of the lunar module Apollo 5. Yeah. And the first successful manned Apollo mission, that was Apollo 7 in October 1968. And they used the Block 2 CSM with all the safety improvements.
So in a way, Apollo 1 paved the way for the moon landing.
It did, but at a terrible cost. And it's important to remember that Phillips report.
Yeah, that internal review that exposed all the problems at North American Aviation before the fire even happened.
They knew there were issues, but they didn't do enough to address them. And then when it came out, NASA looked even worse because they tried to hide it.
Transparency is key, isn't it?
It is. So what have we learned? That the Apollo 1 tragedy, it was a combination of so many things. Design flaws, oversight failures, communication breakdowns, safety oversights, and that pure oxygen environment, it just made everything worse.
It was a perfect storm.
And we can't forget the human cost. Gus Grissom, Ed White, Roger Chaffee, they gave their lives. And we have to remember them and what they taught us. The Space Mirror Memorial, the granite benches at Launch Complex 34, those are there to remind us.
And the thing is, with all the pressure they were under, the rush to get to the moon, you have to wonder, how often does this kind of thing still happen? Maybe not with such tragic consequences, but are we still cutting corners, overlooking safety issues, not communicating properly?
It's something to think about, isn't it?
It is. We have to learn from the past, or we're doomed to repeat it.